Today's April 20th, 2017. Today we have a very special guest, my friend DeVonte Applewhite, who is a software engineer at Intel. DeVonte, welcome to the show.
Thanks for having me. I appreciate it.
So DeVonte, I was reading your bio and you work at Intel, and I'm familiar with Intel because my CPU is from Intel. Could you talk to us about what Intel does?
So Intel is a hardware company. This company also develops software, but it makes CPUs as well as various other types of hardware chips to achieve various goals. It could be anything from running a general purpose computer, such as your laptop, or it could be something very specific. An industrial machine may use a specific chip for that. But yes, Intel is very diverse in that it can have hands in things that everyday users use, such as laptops and desktops, or it can be able to service industrial means. So Intel ultimately wants to make CPUs and chips that can service almost any customer.
And the specifications probably depend on what kind of context it's used in. And you mentioned that it can be for personal computers, it can be for industrial usages, it can be for supercomputing. Could you talk to us about what a CPU is in general?
A CPU in general is a particular piece of hardware that is just general purpose. It takes instructions and it executes those instructions, and it does that continuously as long as power is supplied to it. So in this case, for your computer, it gets instructions on how to run your operating system. The operating system in question could be Windows 7, but all of that is expressed through source code made through a programming language to do a task. That is ultimately what a program is. So you can think of a CPU as running various programs. It takes instructions, it does instructions, and it waits for the next instruction to do it.
And you chose Intel, and I wanted to hear from you why you chose to work at Intel over other opportunities.
I chose to work at Intel because, firstly, it is a very large company, and it amazes me that with over 100,000 employees, it is still able to turn the profits that it does and to create the solutions that it does. To have all of these working parts come together into something cohesive takes a lot of communication, dedication, planning, execution, all of that. And the fact that this entire pipeline is so solid, that's something that Intel does very well. And I felt that I could get something out of that, being a part of that pipeline and seeing how such a large company works.
Gotcha. So Intel is a hardware company, and you chose a hardware company over a software company. First of all, could you talk to us about the dichotomy between working at a software company and a hardware company? Talk to us about the differences between the two in general, what the merits of working at a hardware company is as opposed to working at a software company.
Just a quick question. Should I do this with the perspective of a software engineer or a employee in general?
You can choose to answer however you want.
Okay, I'll just do it with the perspective of a software engineer because ideally this distinction will make you decide which direction you want to go. So for a software engineer, if you're looking at a hardware company and a software company, you have to think about what you're into. So if you really like low-level things such as embedded designs, chip configurations, firmware, things like that, then if you have that software background, but you are able to understand the hardware and that is your interest, then a hardware company on average will meet your needs a lot better.
DeVonte, what is hardware for the audience?
So hardware, think of it as something tangible, and it is a collection of circuits and gates and things that you can actually touch. So a CPU will be considered hardware because it is physical. You can see, if you open it, the transistors and the items that are soldered onto some physical unit. Software is abstract in that you can't touch it. It's intangible, but it is an expression of code that is compiled into a set of instructions that your computer or some piece of hardware follows. So think of it as an instruction set. Do these tasks, and that is your program, and that would be considered software.
And the hardware has to interact with the software, obviously.
Yes. and you need some common interface between the hardware and software. And ultimately, that is, you need the hardware's machine language, the language that the hardware understands. And the software needs to be able to bridge that gap between its high level instructions and expressions. And it needs to be compiled down to the literal ones and zeros that dictate what is the specific hardware understands. So the particular operation code, X amount of ones and zeros, will correspond to something that the hardware understands, and it will execute that task. And you give it another instruction, which is another set of ones and zeros, and then it knows how to do that task. But that's all it knows. There needs to be a way for you to go from your high level language of, okay, here's an operating system, or here's a program that adds two numbers together, and how to go from that all the way down to the ones and zeros that does the task that you needed to do.
Gotcha. We're going to go back to the younger days of DeVonte, living in Indiana. DeVonte, when you were in middle school and high school, were there any episodes that motivated you to enter software engineering?
So, not so much for middle school. In middle school, I loved technology and video games. I was really into it. I like electronics. But in high school, my high school algebra teacher, he showed me how to program on the TI-84 graphic calculator. And I found it really cool that you can make a program that does the quadratic formula for you, for example. So you don't have to even do that by hand. And the idea that I could program that and I can give it a solution and it does what I could do with my hand, but in a fraction of the time, that was absolutely amazing. And that really blew my mind. And so I was really interested around sophomore, junior year to really understand how this works. And so I took it upon myself to look up different programs that I could try to write. Keep in mind, this is just a calculator. So, and it also used a very basic language. Literally, it was called QBasic. And so I could only get so far with that language, but I think it was a great precursor for me wanting to do computer science because I knew I wanted to do some type of engineering, but I really was not leaning towards mechanical or electrical, chemistry, so chemical. That really wasn't my interest. But the idea of programming and being able to automate things and being able to create through these expressive languages called programming languages, that was what really drew me in. I didn't have programming in my high school, but my teacher did take some time to show me some things. So I'm really thankful that I consider him my mentor, Mr. Lewis. He is an absolutely amazing teacher who really cares about his students. And that really helped me, it really sparked my interest and go forward into college to do computer science.
Shout out to Mr. Lewis.
Yeah.
DeVonte, the great thing about software engineering is that you can always give it a try, and there's almost no cost to trying it out because if you have a computer, the computer language is probably going to be free, and you can code something yourself. There's plenty of tutorials. There's plenty of people in the community that are willing to help. Would you say that it's one of the best occupations to try out before, convincing yourself that you should try this full time?
I 100% would agree. It is very special, just as you said, in that the startup costs are basically minimal because the average American would have access to some type of computer and internet. And if you have those two, then you have the portal to the information source for trying this out, and you have the literal machine required to try to program and try out computer programming. So yeah, you would go online, you'd find what language you want to learn. Python, for example, would be good for beginners. You would download it, install it, and then you would open up some window, and then you would start using the Python language to do various tasks. Now, you won't know these outside of the box, and that's where, as you said, DH, you go online for tutorials on how do I write things in Python, and it'll give you a general introduction about what that is, and then it'll go through some quick examples to give you coverage on what the language's capabilities are. And then once you get the groundwork, you can just let your mind free. You literally can say, what do I want to make next? And that freedom to just go and write code and then try to see if it works, there's really nothing to lose. And if it doesn't work, you just keep trying again. For example, in the more tangible world, if you wanted to build a bike, you have to buy the materials for the bike. Then you have to figure out, how do I even make a bike? And then you need the actual tools to be able to do the welding, all the polishing, everything. And let's say at the end of the day, you really don't make a good bike and you don't like it at all, and you actually would not want to do mechanics. Think about all the time and the money and the resources you had to spend to get that prototype to figure out that you really didn't want to do that. With programming, you literally download it, you try it out, you compile it, you run it, and if it doesn't work, you can try again. And if at some point you say this isn't for me, what do? You just uninstall the language, you delete those files, and then you move on with your life. So yeah, I would recommend to anyone to try out programming to see if it's for you. But also keep in mind, the community is huge and there's a plethora of information. So if you get stuck, please consider trying to figure out what's going on by looking online for help. Because once you get over those roadblocks, then you'll see that there's more to achieve. And you'll remember what you went through before so that your knowledge grows over time and you'll be able to start contributing to those very communities that help you get to where you are.
And I think, DeVonte, the community really welcomes beginners, especially because domain knowledge is very sought in the industry. I know a lot of people who are studying software engineering in university, they come out and they apply for a job and they're unable to compete with people who actually have the domain expertise in very specific fields. Let's say chemical engineering domains have their own set of knowledge that is required to create great software that's very specific. So I think it's important for a lot of beginners to not discount themselves, look internally, look at what skill sets they have that are unique, and then just pick up software engineering and sort of blend those two together.
I would most definitely agree. This is a very specific distinction when it comes to software engineering. You can have someone who understands Python in and out. They can know how to do X in Python, how to do Y in Python. But then you say, okay, now make a program that gives doctors the output they need to be able to run analyses on cancer cells, or determine whether the patient is in a stable state. No amount of knowing how a programming language works will be able to allow you to bridge that gap to really get into the mind and into that domain to know how do you write good software to service those people who need that tool. So in that case, with the doctor example, having medical knowledge, having a background in medicine or biology, chemistry, that will give you that context that you can then complement with your programming skills to be able to make the software that does the job needed to be done. So although programming is general purpose, like you said, DH, the domain specific knowledge is what makes you very marketable to specific employers.
DeVonte, so you procured the interview and you got the job. We're going to talk about your interview process, and you can be as specific as you want or as very broad as you want. Could you talk to us about the Intel interview experience?
Okay, so with the interview, the way it worked was that at my college, I went to a career fair. And then from there, I talked to the people at the booth and I said I was interested in the software position. And so from that point, I gave them my resume. They looked it over. And then what they did was they called me that night and said, hey, we want to just give a quick interview, get a quick interview for you, kind of feel it out, see if you're a good fit. So the following morning, I have my general interview. They ask you mostly behavioral questions, what would you do in this situation? Or what do you find to be the case for these situations? And then once you get through that, depending on if they know you're going for software, they may ask you some very light software questions, very simple. Well, simple in the sense of like it is going to get harder as you go along, but just the very baseline questions. So they may ask you something like, on paper, write an algorithm that can sort a list of numbers from smallest to largest, and you do that quickly. Or they say, here is a piece of code. It has one error. Where is this error at? And so things like that. And then after that, once they assess that, you could be a good fit just in general, that's when you would do a phone interview. And then the phone interview kind of gets more behavioral just to see where you're at and to see what you want out of the position at Intel. And then if they think that you are a good fit for the culture, this is the second interview just for the good fit, then you may do one of various things, mileage varies, but they may ask, for example, can you get on Skype and then go to this specific website where we can watch you code, and we're going to ask you specific questions, and let's see you code. So then you do that, and if you do well in that, then you'll get an on-site interview where they fly you out, and then you'll kind of do what you did at your university, for example, or when they just were giving you general behavioral questions and then technical questions. But the distinction is you're going to be targeted towards a team or a group of teams. And so these hiring managers on each respective team is going to try to assess and see if you'd be a good fit. So they may send some of their individual contributors that they manage and say, interview them on this. And then you're going to meet various team members, and each team member is going to assess you. And then those assessments are aggregated. And then each manager kind of gets a feel for the candidate by actually interviewing them. And then the collection of the individual contributors who interviewed you, as well as the hiring managers who interviewed you, they'll decide whether they want you or not. And if they do want you on their team, then they're going to see if you really have the skills and you will be a good fit. And if they feel that, then they're going to put out an opening for you to be a part of their team. It's totally possible that two hiring managers could want you, and then now they have to negotiate on, well, how many open positions do you have, all that. But that's stuff you really don't have to worry about. Ultimately, you need to just focus on making a good impression and being confident in what you do. And throughout this process, I think it took about a month for me. It could be a month and 2 weeks for some, and as short as 2 weeks. Some people get offers on the spot if they are, that captivating. So, that's why I say mileage varies. It could be anywhere between on the spot and then you fly out. So basically a week or two, or it could be as long as a month and a half where they do various rounds of interviews.
So patience is important.
Patience is important, and making sure you're persistent but not rude. If the person who's been in contact with you doesn't answer you in 2 days, don't worry too much. It's not the end of the world. Also keep in mind they're still running their full-time job. But, past that, just send a polite email. Hey, any status update, anything I should keep in mind? And then they'll usually update you, it behooves them to get new talent, so that's the key. So yeah, patience, persistence, and just ultimately following up. It's unfortunate when certain interview processes take a long time because it's on the onus of the employer to make sure they're giving you the information you need. But just for your sake, make sure that if they ever give you something, you're on top of that. And basically, you can turn around and send them back exactly what they need as soon as possible. But, of course, make sure it looks good. Don't try to send anything sloppily or hastily, but just send it back so they're never like, wow, why didn't that candidate send me this? It's been, 2 days or 3 days. Never let them be able to even say that about the process. So if you're on top of your stuff, then it's on them to make sure that they're doing what they need to do to assess if you're a good candidate or not.
And please don't write a diss track.
No, none. It won't work.
You'll never get employed if you do that. I almost wrote one.
You did? Ooh.
Yeah, but I can't rap.
Oh, it's okay, man. We all have different skills, and it's possible to develop it. It just takes time.
DeVonte, would you say that there are any strict educational requirements for getting the job? I know you went to college, a pretty reputable one at that. Is it possible that people can possibly drop out of college, not go to college at all, or maybe go to a lesser represented college and still procure a job at a pretty high-profile company?
I don't know if Intel has a hard requirement for a degree. I can't speak on that. You would have to talk to an Intel hiring manager or look online for whether all the open recs have, bachelor or associates. But regarding people who go to colleges that maybe, Ivy League, all the way down to any college that spans any set of notoriety, if you do well at your college and you reach out to Intel and you show your resume and it looks solid, and for example, if you have projects to back it up, then they're going to assess you as an employee, and they see, wow, okay, this person looks like they really could do good work here. So I've seen people at Intel who have come from various college backgrounds from all over the world. So I think that you in general should not worry about what college you came from when applying to Intel. Now, of course, if you do have an inclination to change colleges and to get somewhere that you think will make it easier for you to get in because maybe the college is more notable or they have a direct pipeline to Intel because Intel has the relationship they want to facilitate with that college, then yes, it behooves you to get into that college if you have a way to. But otherwise, I would just say focus on your skills, focus on your major, and make sure that you understand the material because a confident and competent employee will beat anyone who's from a very notable school who really doesn't have that ground understanding and go getter attitude to get things done.
DeVonte, can you talk about particular classes or majors you would recommend? I know that we talked about domain knowledge. So if we just say only study computer science, that would be contradictory to kind of the point of domain knowledge that we brought about.
Okay, so I mean, computer science is definitely a staple. It's really good to have that knowledge. Consider computer engineering or even electrical engineering if you're more on that technical side, the more hardware side. But to complement that, I think it'd be great if you would do some type of business program in tandem with that. The knowledge of business, just being business savvy and having that acumen, if possible, will complement any person who has computer science knowledge because not only are you able to develop the product, but you can think about what is the market that we would be able to breach with this? What type of people are we reaching? How important is it that we get to market at this time? Or, is the product we're developing even going to last for the next 5 years, or is something bigger going to come along and then sweep us under the rug? Having this knowledge can make you invaluable as an individual contributor and even a manager in the long run if that's the route you want to take. So I would definitely recommend business. Economics too, that's invaluable. Statistics, they're all very mathy in ways, but it's also good to have a background in biology. There is biomedical engineering, and you compare that with things such as iris recognition, analyzing cancer cells, all this stuff. You need that specific domain knowledge to be able to do the things that relate to biology because technology and the living world are getting more integrated. We have pacemakers, that's a small example, and then now we have things such as Fitbits, and they read various metrics on the body to be able to give you a concrete answer on what's going on. And you need that domain specific knowledge to be able to create that software or that hardware to do those tasks. Besides biology, you could consider chemistry or any of the physical sciences, but it would never hurt to do anything such as sociology or psychology, because if you think about it, that's just really good to know in general. It gives you a context for people in general, maybe the way they think, the way society is, and these can give you invaluable parallels for how to approach problems or situations. Ultimately, the more diverse your knowledge set, the more valuable you will be in the long run. It may be completely true that first project you're on, you don't even touch or use some of your other knowledge, but you really don't know if you're using it or not because it's so integrated in your skill set. You may be using stuff you didn't even realize because you're just trying to get the task done, and you're taking your worldview and what you've learned to apply to the situation. And you having that background would mean that you might not even approach that problem the same way someone else with a completely different background does. And ultimately, you all can learn from each other, and that's what allows us to grow. So if we all had the same background, we'd be solving problems the same way all the time. And that's not how innovation grows. Innovation thrives in diversity of thought in many other ways, and just trying things because the solution is not always clear. And sometimes very uncommon ways of getting to a solution could actually be the better way in the long run.
In summary, we can probably study anything we want, I guess would be how you put it. Study whatever you want.
Yeah, basically.
Basically, that's such an open-ended answer there, but I think it's kind of the point that software engineering is open to all people of all backgrounds, educational requirements. Please come forward and let's learn together. DeVonte, we can't thank you enough for joining us today. Some of the audience tuning in will identify their passion with your occupation as a software engineer, perhaps try to strive for working at Intel and pursue that as a goal. And that's always a great feeling to be having, that we've helped people. Now, if you could give one final message to those people wanting to become like you, a software engineer, what would that be?
I would say that definitely go for the goal. If the goal is for you to be a software engineer, you know, put in that extra effort to figure out something that you may not be as good at when you first start off. Because getting through those hard parts is going to be an integral part of your growth. Because as you get into the industry, you're going to face various problems, various tasks, and that growth mindset and also that willingness to overcome adversity will allow you to be able to get through basically anything, and you'll be able to make some absolutely amazing products, pieces of software, documentation. Anything you produce will be basically golden because you have that mindset that you're going to keep pushing and keep driving because you want to achieve greater and better, and you're always open to learning. So lifelong learning, that is a very good skill to have, and that enthusiasm to get through the hard parts as well as enjoy the parts that may be more fun than others. So that's my final message. Just keep at it. Even if it does get tricky at times, know that you will get through it and you'll be able to be even better than before.
Thank you, DeVonte. Talk to you soon.
Thank you.